All right, guys. So back to graphs of parabolas and quadratic functions, and really there's two different forms where you will usually see the equations given as. The one is vertex form. It's going to look like y equals some a value times x minus h squared plus k. Those are the graphs that will open either upwards or downwards, depending on if a is positive or negative. Right, or the other option, if a parabola opens sideways, it's going to be an x equals equation, and kind of everything's just going to be switched around. You're going to have y minus k squared, and then plus h. And again, in either case, the vertex coordinates are going to be hk, okay, and that's why this format's actually kind of useful, because you are able to see the coordinates of the vertex just by looking at the equation. Okay, you really don't need to do any work. You don't need to do a graph necessarily. And it's all because of the shifting, the translation, the horizontal and vertical shifting that shifts the vertex over h amount and then up or down k. Okay, so vertex form is very useful, and we'll look at a couple examples in a minute here. But the other form, general form, sometimes it's called standard form, is going to look a little different. And what that one's going to look like is where it's just y equals ax squared plus bx plus c. Okay, and in that form, that's usually the form you want if you're solving an equation. You know, if you're finding zeros, or you want to do some factoring, or the quadratic formula. But for graphing, it's honestly not as useful as vertex form. But again, it does have other uses when you're solving equations, like we said. Okay, and this one could also be written in the form if it's a sideways parabola. Similarly, ay squared plus by plus c. Okay, and again, we probably don't do a ton, nearly as much of the sideways opening ones, but just to show that they do exist, it could be written both ways. All right, so let's look at an example, because sometimes, again, you're going to want to convert from one form to the other, usually from general standard form to vertex form. So let's take a look at how that works. All right, so here's an example. Can we convert y equals x squared plus 8x plus 11 into vertex form, and then use that to state the coordinates of the vertex, the axis of symmetry, and the direction of opening? Okay, so let's take a look. So again, vertex form, what we want to end up with is vertex form, which we saw is y equals a times x minus some h value, squared plus k. And so we need to do some converting and see if we can get ours to look like that. So let's see what we can do. I'm trying to clean up that. Sorry, I have a little different marker here, stylus, and it's a little bit different. So x minus h. All right, so our problem for this example is y equals x squared plus 8x plus 11. Okay, so first things first, the a value, okay, the a value right here in our problem, you could just think of there being a 1 there. So we know what that is. So the next issue just becomes, how are we going to figure out like this piece? We need it to be some x minus h, and then the whole thing is squared. Okay, so the method we're going to use here is a method called completing the square. It's a little process. It can be used for solving equations and doing some other things too with other applications later. But basically what we're going to do, we're going to look at just this portion right here, x squared plus 8x. Okay, I'm going to leave the plus 11 out here for a second. And what I'm going to do, okay, with completing the square, I'm going to add something here. And I'm going to add something there so that the new trinomial, okay, that highlighted those three terms are going to be factorable into a perfect square. Okay, and here's what I mean. Here's the trick. Okay, we are going to take a look at this value right here. Sorry, I keep forgetting I'm on highlighter. That 8 right there. Okay, that's going to be like our kind of our determining factor. Here's the little process. Okay, you're going to take half of 8. Okay, half of 8, of course, is 4. Okay, so 4 plus 4 is 8. Right, 4 times 4 is 16. Okay, and that's what's going to go right there. okay? And I'll tell you why in just a second. What we need to do though, since we just added 16 to one side of the equation, we have to balance that out by minusing the 16. Okay, now we didn't really change anything. We just kind of added 16 and then subtracted it right off, but we did it for a reason. And here is the reason. Look at the highlighted trinomial now. X squared plus 8x plus 16. That is factorable because there are factors of 16 that add up to 8. Okay, x plus 4 and x plus 4. Okay, now do we see why it's going to become something squared? Because we have x plus 4 times itself, which just means x plus 4 squared. Okay, then we can take a look out here, combine those terms to get the k value out there. Plus 11 minus 16 is really just equaling minus 5. Okay, here's our final answer. Y equals x plus 4 all squared minus 5. Okay, that is vertex form. Okay, and the reason it worked again was because we chose the right number, right? We completed the square right here by doing that process where we used the 8. We took half of 8 to become 4, and then 4 squared got us the 16. Okay, here's what this does for us now. This tells me that this graph, okay, if we think about the shifting and stuff that's going on, we have an x plus 4 in parentheses, so I know the vertex is shifted to the left 4 units. And we have a minus 5 outside, so I know the vertex is down here at negative 4. Remember, it's always the opposite of the term inside, and then the actual value of the term outside. So negative 4, negative 5 is the vertex. Okay, our a value, we actually knew that from the very beginning, is 1. So this graph opens upward. Okay, now I'm not going to get super accurate, but we know it opens upward. Okay, and we also know one other thing, this axis of symmetry. Okay, all of these parabolas have an axis of symmetry that goes right through the vertex. Okay, and what symmetry means is like it's the same on both sides, like a mirror reflection. So in this case, the axis of symmetry is just going to be the vertical line of x equals negative 4. Okay, I'm going to abbreviate that AOS, axis of symmetry. So it's just, in this case, the x-coordinate of the vertex. Okay, so this thing opened upward, we have its vertex coordinates, and we have the axis of symmetry. Okay, now take a look, one last thing. Just by having the equation as they originally gave it to us up here, I would not have known the vertex, the axis of symmetry. I would have known it opened up, right, because it was positive x squared, but other than that, we wouldn't know anything. Okay, so getting it in vertex form gives you a lot more information about the graph. Okay, let's do one more example then here. This one, again, same thing, we want to convert. Let me just rewrite here, y equals, we have 2x squared plus 8x minus 9. We want to get that into vertex form, so again, that we'll know some properties about the graph. Okay, this one's a little bit different. There's one more piece of the puzzle we need to be careful with. It has an a value of 2 there. So what you want to do, you want to factor that out. Because remember, vertex form has the a value factored out before the x minus h squared plus k part. So we're going to factor that 2 out, but we're only going to worry about those first 2 terms, okay, initially here. I'm going to factor the 2 out of those 2 to get x squared. And that 8x, if I factor a 2 out, is going to become plus 4x. Here's where I'm going to add something to complete the square like we did before. And then that minus 9 is just sitting there. You might want to put a little space there to remind yourself. Remember how we balanced out? Whatever we're about to add in the first blank, we need to subtract off or balance out in the second spot. So let's do our little process now. And again, I'm looking at this 4 right here. You always look at that b value, the middle term. So we're going to take half of 4, which is 2, and then square that. So 2 squared is really plus 4. Okay, half of the 4, and then square it. So in this case, we need to figure out how are we going to balance this out. And it's not going to just be a minus 4, because that plus 4, where we put that, is really in the parentheses getting multiplied by 2. So by putting that plus 4 there, we kind of really added 8. Okay, because again, it's getting times by that 2. So if we're adding 8, we need to balance that out by subtracting 8. Okay, so let's take a look and keep going on this. All right, so when we go to factor this out, okay, and we're going to try to get, we're going to try and get this portion of it now. So it's going to be y equals, we have the 2. Okay, this right here, again, needs to become a perfect square trinomial, meaning it's the same factor twice, right? It's x plus 2 times x plus 2, right? Because I was looking for factors of 4 that add up to 4. Okay, then on the outside it's minus 9 minus 8, which is minus 17. Okay, now here's how we can write this, that we have x plus 2 written twice. When you have something times itself, it means that it is squared. Okay, this is our vertex form now. Okay, so we should know, just from that form, we should know the coordinates of the vertex are going to be, again, it's the opposite on the inside, so negative 2 for the x, negative 17 for the y. This thing opens upward because our a value is positive, right? It was a positive 2, we knew that right away. And then so the axis of symmetry again, okay, actually I have this one graphed, I just want to bring the graph in to show you guys down there. The axis of symmetry, as we can see, since this graph opens up, just like the previous example, our axis of symmetry there is going to just be x equals the x coordinate of the vertex, which was negative 2. Okay, so transforming to vertex form again is very informative. It really helps because, again, looking at the original function as given, you know, up here, I didn't really know anything except the graph opened up. Okay, it actually it does give you the y-intercept. If you take a look at that c value, the negative 9 there, that is going to be the y-intercept of the graph, as you can see down here. But other than that, I mean, it's not giving you the vertex, it's not giving you the axis of symmetry or anything. Okay, so make sure we're able to convert back and forth. And again, that process of when we're deciding what to go here, that is called completing the square. Okay, all right.